Hello students, I am Dr. Tanmoy. I welcome you all in my channel TanmoyChem. Today's topic of discussion is on MCQ and the question is in front of you. I request everyone, please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. I believe we have tried, so let's start. Now the question, which one among the following compound will give effervescence with sodium bicarbonate? Actually, it's a test of acidity, means if you look at, there are four compounds: carboxylic acid, sulfonic acid, phenol, and this derivative of phenol. So now which one will not give effervescence? Now this question could be asked in a different way, that is, what is the acidity order of this compound? And obviously the lowest acid will not give effervescence. So that's the actual question. Now whenever the question about acidity asks to you, you need to remember one thing, that acidity of a compound depends on the stability of conjugate base. And remember, the higher the stability of conjugate base, higher will be the acidity. Then your obvious question will be, sir, what is mean by conjugate base? If you remove proton, for example, from here, if you remove this polar proton, there could be many protons, student, but polar proton, here I am talking this OH. So polar. So removal of this H plus. If you remove H plus from this neutral molecule, there will be anionic species. These are actually, student, the conjugate base. Now, if the conjugate base is more stable, obviously the compound will be more acidic. Now, if the conjugate base means among four, which one is the least stable? So that will not be able to produce effervescence. So let's look at the stability order. Now if you look at, this is a benzoate. So how could be stabilized? By this resonance. So in this resonance, you can see, by the way, I'm representing this 6-member ring as pH. So here it's O minus, this is double bond. So you may think, sir, what will be the electronic distribution? This electron density distributed over both of these two oxygen equally. Now if you say sulfonic acid, so one resonance will be this way, another will be this way. So two canonical forms are possible. By the way, I am not drawing. I suggest you please try by yourself on your pen and paper. Now if you say, sir, how the phenol, means the phenoxide is stabilized, so it will come here, it will go, means directly by the participation of this benzene ring, the phenoxide got to some extent stabilization. By the way, there are total 5 canonical forms, so others you can draw, means it will come, it will open, like that. I am not going. Now this is also a phenol derivative. Now extra is nitro. How this nitro affect the stability? If you look at this, nitro structure is actually like this: single bond in O minus above nitrogen positive, and there is a double bond. So what happened? These electron density push here, it goes there, it opens up. My purpose is to show you the contribution of nitro group in stabilizing the conjugate base. So here there is a double bond in O minus, there is a positive charge on nitrogen. By the way, there are two nitro group there as it is. And remember, these nitro groups are actually electron withdrawing group. And it is situated at 2, 4, 6 position, means it can directly participate in delocalizing the benzene ring pi electron density. And remember, higher the delocalization of electron, higher the stabilization. And the rule we have studied, higher the stability of conjugate base, higher will be the acidity. And in this case, since this conjugate base means actually the anionic part of picric acid, if you look at here, the negative charge is more delocalized because of the presence of 3 electron withdrawing nitro group at 2, 4, 6 position. So that's why it is more stable. So obviously it is more acidic compared to which one? Phenol. Now if you think from every angle, so what is actually the acidity order? If I say sulfonic acid maximum 1, second position goes to second position goes to this one, this trinitro phenol, and the third position goes to benzoic acid, and fourth one is phenol. So obviously it will not be able to produce the effervescence from sodium bicarbonate solution. So this is my answer. Now if you get this question in your exam hall less than 30 seconds, how could you solve? You need to understand, or I suggest that please remember that carboxylic acid or stronger acid than carboxylic acid can produce effervescence of CO2 from bicarbonate. So what happened here? This bicarbonate actually react with its stronger acid, means if I say it's a carboxylic acid, So it produces, remember, this one is actually my stronger acid. So obviously it can react with bicarbonate and produce the corresponding weaker acid, carbonic acid. Okay, so this is weaker, and remember, stronger acid to weaker acid production is thermodynamically favorable. And what happened, this carbonic acid again decomposes, it's not a stable molecule, into CO2 and water. And this CO2, because of buoyancy, comes out or shows effervescence. So this is actually a detection test for carboxyl group or other stronger compound, but generally I would recommend that this is a detection test for carboxyl group. Phenol does not give this test. By the way, it's not phenol, just unsubstituted phenol. So if you take this 2,4,6 trinitrophenol or 2,4 dinitrophenol, means this nitro is absent that time. So that also give positive test with bicarbonate. Why? It is stronger acid than phenol, means the negative charge, I mean phenoxide, is stabilized more by resonance due to the participation of this electron withdrawing nitro group at 2,4 position. Okay, so this is the answer. So if this question appear in your exam less than 30 seconds, you should remember this information. Pure phenol doesn't give the test for sodium bicarbonate. You don't need to think others also. Okay, so now in conclusion, what you have learned, that acids stronger than carbonic acid, where pK means carbonic acid means H2CO3, pK is 6.35, will produce carbonic acid from its salt like carbonate or bicarbonate. And since it is not stable, it gets converted to CO2 and water, and this CO2 shows effervescence. Next point, phenols generally can't produce CO2 from bicarbonate. It is weaker acid. By the way, you may ask one question, sir, that phenol case there are 5 canonical forms, whereas in case of benzoate there are 2 canonical forms. So why phenol is less acidic than benzoate? If you look at, in case of this benzoate, the negative charge 2 times on more electronegative atom oxygen, means it is more stable. If you look at phenol case, except the first one or the last one, the negative in these 3 canonical forms, I mean this one and this one, the negative charge is on carbon atom, which is neither electronegative nor electropositive. So that's why the stability of this canonical form is not much higher compared to this carboxylate. So that's the reason it is comparatively lesser acidic, and that's why it cannot produce effervescence from sodium bicarbonate except 2 or 3 nitro group present in 2,4 position or 2,4,6 position. Okay. Next, acidity of a compound depends on the stability of conjugate base. Higher the stability of conjugate base, higher will be the acidity. And here, if you look at, the conjugate base is stabilized by resonance, I've already shown. So this is the overall discussion. Thanks for watching. See you in my next video. Bye bye.